Hello, everyone. We'll get started now. Thank you for joining me this afternoon. My name is Kristen Neath. I am the Canadian National Sales Manager at Kinetics Noise Control in our commercial, industrial, and environmental markets. Kinetics Noise Control is based out of Dublin, Ohio. I am located in the Canadian sales branch in Cambridge, Ontario. Today, we're going to be discussing duct silencers. We'll go over the types, performance, and proper applications for them. I won't be taking any questions during this webinar today, but please feel free to leave your questions with the answers. So starting with why HVAC acoustics. HVAC equipment is a major source of noise inside a building. So it's going to contribute to the overall level of occupant satisfaction within a space. Looking to the outside of the building, that same HVAC equipment can be a noise concern as well. Here we're dealing with municipal bylaws for sound levels outside the building. And lastly, the incorrect selection of these products can impact the performance of a whole HVAC system, whether that's balancing the system or could be even a necessary cost. Selecting the wrong product, using it for the wrong application can add these extra costs unnecessarily so in a lot of cases. So what is a silencer? Now, I call it a silencer. Some people call it an attenuator. It could be a sound trap. This tends to be a regional thing. I'm going to continue to call it a silencer. They all refer to the same piece of equipment. And what it is it's designed to replace a piece of ductwork. So looking at the image on the right of the slide here, those hatched areas are silencers to be used to supply return exhaust air for that air handling unit. Our standard configurations for a silencer are rectangular, elbow, circular, but we can pretty much fabricate these out of anything we can make sheet metal with. We have a lot of variation in custom designs we can do. The performance of the silencer characterized in three ways. So we have the insertion loss, the pressure drop, and the generated noise. So what the insertion loss is, when I talk about the acoustic performance, I'm talking about the insertion loss of a silencer. What this is, it's the difference in sound power levels in a system with and without a silencer. So on the right of the screen here, you can see a standard Kinetics submittal. About halfway down the screen, there's a red box, and inside that red box, it says dynamic insertion loss. You can see 8 different frequencies. We work from 63 up to 8,000 hertz. And at each one of these frequencies, we have an insertion loss number. This is the amount of sound energy at that frequency that's being taken out by the silencer. We would want these insertion loss numbers to be the same or higher than what's required for a space. Next, we have the pressure drop. Now, this is the consequence of adding a silencer to the system. You don't get something for nothing. We're creating an obstruction in the airstream by adding the silencer. That obstruction is going to cause a pressure drop. We measure when we list this on our submittals as well. Lastly, we have generated noise. Now, generated noise, the same way that the pressure drop is generated, we have turbulent airflow, we have an obstruction in the ductwork. That turbulent airflow and obstruction is going to cause some noise to be generated. And that's what those numbers are. Now, for the most part, if we look at those generated noise numbers and we compare them to the sound power levels of the unit the silencer is servicing, usually these generated noise numbers are quite a bit lower, and in most cases they're negligible when we consider the sound levels over the entire system. There are some times we do need to consider those generated noise, and that's when we have rooms or spaces that require an NC20 rating or lower. We're looking at spaces like performance halls, recording studios, things of that nature where sound is very, very sensitive. The way we get these performance numbers is through the ASTM E477 test standard. At Kinetics, we use impartial third-party testing. We send our silencers to get tested by an impartial third party. And they use the ASTM E477 test standard to measure the insertion loss, generated noise, and pressure drop. What's important to note here is that the pressure drop is measured under ideal flow conditions, and we'll get into why that's important in a couple of minutes here. This is the inside of a silencer. It does look a little bit funny because this is a sample, but we'll go through some of the main features here. So the first one being the outside casing. This is what holds the silencer together, and we're going to choose or select the casing based on what the ductwork is. So generally, it's going to be the same casing thickness, or sorry, gauge thickness, as well as the same material. So our standard would be a 22 gauge galvanized steel casing, but we can also do 304, 316 stainless steel. We can offer aluminum. We can go to thicker gauges like 16, 12, 10, etc. Next, we have the baffles. Now you'll see the baffle refers to the entire assembly. You can see one big one right in the middle of the silencer and then two on the outside edges. The baffle's made up of a couple components. So looking at first the rounded nose cap, that's right at the inlet of the silencer, and then the pressure regain tail, that's at the other end of the silencer. So the air would flow nose cap to tail. Those are there to help with the aerodynamic or pressure drop performance of the silencer. It's going to help the air flow better through the silencer, reducing the pressure drop of the silencer. Next, we have the perforated sheet metal. Now, that perforated sheet metal is there for two reasons. Number one, it's going to hold that acoustic media in place. It's not going to fly away with the airflow going through the silencer. Number two, we use a perforated sheet metal because that allows the sound energy that's in the air to enter into the baffle and then dissipate with the acoustic media that's inside of there. Lastly, we have the double retainer. Now, the double retainer works because it holds the baffles together, so it sits in what we call the air gap. That's the space between two baffles where the air flows through the silencer. And what it does is it increases the stiffness and rigidity of the silencer, which adds to the overall quality, but it also helps to keep the sound in through that air gap. It's going to having that extra double retainer on the top and bottom of the silencer is going to make the silencer better able to hold in that noise as it's attenuating the sound. There's three stages on how the silencer works, starting with the inlet. This is where we're going to see a lot of that turbulent airflow. This is where the airflow first encounters the silencer. As that air hits the baffle, we're going to get some turbulence that happens there. That air is then compressed into the air gap, and so we find that the velocity increases as that air is compressed. We'll have a small amount of insertion loss that happens here, specifically in the high frequencies, just due to some sound wave reflection off of the baffles. And then we get a small amount of pressure drop here due to the turbulence and the compression of the airflow as well. Next, through the passage of the silencer, this is where the majority of the insertion loss happens. This is where the airflow comes in between the baffles, it's compressed, it accelerates, that sound energy then goes through that perforated sheet metal to the acoustic media where it's dissipated. And then we do get a small amount of pressure drop here as well. Now, definitely not a significant amount, it's mostly just due to some friction losses as that air travels over the perf. And then lastly, we have the outlet of the silencer. This is where the air is redistributing back to the duct size. We're going to get a small amount of low frequency insertion loss here. There's going to be a little bit of reflection of the sound wave that happens as that air expands. But this is also going to be the largest contributor of pressure drop, and that's just due to the sudden expansion of that air back into the size of the ductwork. This is the reason why we add that pressure regain tail. So that's going to reduce the overall pressure drop by about 15% by having that there. So a couple slides ago, I mentioned that the submittal pressure drop for a silencer is under ideal conditions. When I talk about ideal conditions, it means that we have about 3 duct diameters before the silencer of straight unobstructed duct, and about 3 duct diameters after the silencer of straight unobstructed duct. As you all probably know, that very rarely happens. Usually we have different duct elements before or after the silencer. These are all going to have an impact on the overall pressure drop or the overall installed pressure drop of the silencer. When we don't know what these system effects are yet, we're going to design the silencer for about 0.2 inches of water gauge or 50 pascals. When we do know what the system effects are, we're going to design for about 0.35 inches. Now, the way that these duct elements interact with the silencer is we apply a factor based on what the element is and how close it is to the silencer. Now, on the right there, you can see a chart that's just out of ASHRAE. That's a brief table that goes over a couple examples. You can see the factors there. And here's an example. So in that image on the right, there's a blue box there. That's a silencer, and that's serving the outside air for a unit. Our upstream condition, we have a louver that's pulling in outside air. We're going to consider that a sharp, abrupt entry, about 1 duct diameter from the silencer. That condition, that inlet condition, is considered we would give that a factor of 1.1. The downstream condition of the silencer is a radius to elbow, again, roughly 1 duct diameter from the silencer. That's assigned a factor of 1.2. So when we put this all together, we have the ideal or silencer pressure drop of 0.25, the inlet condition factor, the outlet condition factor. When we put that all together, we end up with a silencer that actually has a pressure drop of 0.33 inches of water gauge. That's the installed pressure drop. So you do see that where the silencer is installed does have an impact on the overall installed pressure drop of the silencer. Now, like I said, we do have 3 different standard types of silencers. The first one being rectangular. This one is by far the most versatile. So when it comes to the baffles inside a rectangular silencer, we do have the greatest versatility here with the size of the baffles we can use as well as the configurations of them. The configuration becomes important because then we can start tuning our silencers to be good for low frequency noise or mid frequency noise or high frequency sounds. The rectangular silencers, because we have that versatility in the baffles, we can also make them well suited for low, medium, high velocity applications. And then we're going to be able to get a good balance of acoustic performance, so insertion loss and pressure drop. These silencers are really good to go in long duct runs or chases, places where you will actually start seeing those ideal system effect conditions. Next, we have an elbow silencer. So we generally suggest these when an elbow or when a rectangular silencer just won't work, usually due to a space constraint or a poor system effect condition. So you can see the image on the right there. We don't really have a lot of room in that mechanical room to put a rectangular silencer. So this is an application where an elbow silencer really works. Because generally we can get the same or better performance with an elbow silencer versus a rectangular. We just have to make some considerations for the pressure drop. They are better suited for lower velocity applications, so usually around 1500 beat per minute or less. When it comes to system effects, sometimes we'll have a system where there's 2 mitered elbows, and between those mitered elbows there's a rectangular silencer. Well, that's a really poor system effect condition. So what we would want to do in that case is replace one of those elbows, mitered elbows, with an elbow silencer, and that improves the overall system effects. Lastly, we have circular silencers. So we most often see these on circular ductwork. It fits much better. Now, we also see these in high velocity applications as well. So the reason for that being is if you look at the silencer in the bottom right corner there, you can see that circle on the front, that's the size of the ductwork. That's what's going to connect to the duct. And then all the acoustic media is outside of the silencer. So we're not obstructing, we're not impeding that airflow at all. So we can get some insertion loss, we can get some acoustic performance without a substantial pressure drop penalty from the silencer. Now, there are applications where we will need more insertion loss, so that's where the silencer on the left comes in. We add a bullet to the silencer that increases the acoustic performance. We can also size that bullet differently, so we can get a good trade-off between insertion loss and pressure drop. Now, that being said, those are just our standard models. We can make silencers in all different shapes and sizes. Here are just a couple of other examples. We have extended casing silencers silencers with circular end caps, T silencers, which are really good for use with rooftop units, crosstalk silencers. And like I said, if we can make that a sheet metal, we can make it into a silencer. We have a lot of expertise, and we're able to design silencers for a lot of different applications. So here's where we get into why this silencer looks a little bit funny. We're showing the 3 different types of acoustic media we have. In that center baffle, that's fiberglass. That's our standard acoustic media. On the right there is a treated cotton. And on the left is a packless. You might hear this called no media reactive. And what this does, instead of having acoustic media that absorbs that sound, it has chambers within the baffle where the sound enters in and is dissipated just through a small amount of vibration. Comparing these different media types, so for fiberglass or EnviroGreen cotton, these are really useful or really common with commercial, industrial, institutional type applications. You'll see these in schools, courthouses, shopping malls, etc., things like that. The only real difference between the 2 of these is we wouldn't want to use the EnviroGreen media for any sort of humid settings. We wouldn't want to use this in a pool application or something like that, just because the cotton has a tendency to absorb some of that moisture. When we compare the acoustic performance of these 2 medias, they're about the same. We don't see any real difference in acoustic performance, but the cotton media is a premium product. So there is a cost associated with moving from the fiberglass to the EnviroGreen. When we compare this to the packless silencer, these are really specialized. The packless are usually reserved for things like operating rooms, fume hood exhausts where there could be some chemicals in the airstream, clean rooms, applications where we would want no fibers whatsoever in that system. Now, we're comparing the acoustic performance of a packless silencer versus a dissipative type silencer. You're going to get a lot less acoustic performance out of this one. It's also a premium product. It's quite expensive, comparatively so. So it's really reserved for those applications that really need it. Next, we look at the media covering. So going back to how the silencer works, as that air is compressed and moves through the silencer, that velocity increases. We have an area of low pressure in that air gap there. It can pull some fibers into the airstream. If velocities get high enough, we can start losing some fibers. Now, that's one of the reasons why we have that perforated sheet metal liner there. That's going to hold the media in place and stop a lot of that shedding from happening. There's actually a study that showed that there's no evidence of erosion or flaking off at velocities up to 10,000 feet per minute. But there are times we would want to consider adding different media linings. So if we're getting to velocities up to 2,200 feet per minute, we might want to add a fiberglass cloth, and that fiberglass cloth just goes between the acoustic media and the perforated sheet metal. And that just stops any sort of fiber erosion at that fast velocity. We would also want to consider adding a liner if we have a hospital grade silencer. And so that just prevents any of the fibers from entering into the airstream. So comparing the different media lining types. So no lining, we're going to see that most of the time. That's going to be most of your commercial building. That's going to be most of your institutional buildings. Your schools, courthouses, shopping malls, office buildings, things like that. They don't require any lining. The media is perfectly protected being behind that perforated sheet metal. As the velocities get higher and we get into industrial applications, we do want to look at putting a fiberglass cloth between the perf and the media. And we look at that around 2,200 feet per minute. We don't see any real difference in insertion loss performance at this point, but we are looking at, again, adding a premium to the silencer by including that lining. Now, as we compare that to the film lining, we want to reserve this for things like hospitals, medical offices, healthcare facilities, even some clean rooms. Comparing the insertion loss qualities of the silencer, again, it's going to degrade the performance a little bit. Now we do add an acoustic spacer, which does help to boost the performance a bit, but we're not going to see the same kind of insertion losses from a film line silencer as we would a silencer with no lining. Again, that film lining does add a premium price to the silencer, so we want to make sure that these linings are really reserved for applications where they're absolutely necessary. Just to reiterate that further, here we have a chart or a graph that shows the difference in insertion loss performance of the three types of silencers. So looking at that blue line is just a standard fiberglass silencer. You can see that especially through the mid and high frequency bands, we're going to get the best insertion loss performance. As we move to a silencer that has a Tedlar lining on it or a film lining, it does degrade the performance in the mid to high frequency bands. And then as we move to the packless, pretty much through all frequencies, we are going to see a degradation of performance. It's just not going to perform as well. So keeping in mind that these silencers are reserved for very specific applications, we don't want to add any unnecessary cost to a project by adding in these premium products. So I want to thank everyone for your time today. Thank you for joining me. I have listed a couple of websites here, so if you're interested in more information on duct silencers or our commercial markets, the websites are there. I've also listed our rep locator, so you can find your local contact. For those of you located within Canada, you can contact me directly, or you can reach me through the Canadian sales email that's listed there. For all of you that are located outside of Canada, please feel free to reach out to Silencer Sales with any questions. As I said at the beginning, please feel free to leave your questions in this webinar, and I will reach out to you afterwards with some answers. I'd like to thank you again for your time today, and have a good day.